Okay, so carrying on with this, sorry about the slight delay, I'll merge them together, it's seamless. Why have we only got 1 mark of this so far? 2 marks of this? That's not the right answer. Because it said show that they only have 1 root. Exactly 1 real root. We haven't done that, we've just drawn the graphs. It is there, but you have to show that you know that it's there. Either with just do a little circle around it or an arrow to it, exactly 1 real root. There it is. It is irritating, but you have to do it. So, part 2. Use the iterative formula to find the root correct to 3 significant figures. This we should ace this. This is 4 marks. These should have been the 4 most secure marks on this paper, or any paper in the world, ever. So, what does it look like? I haven't got a paper. That's 42. What next? That one is right. What did it say?
Not the right answer.
X n plus 1 is cos to minus 1 x to the n over 2xn plus 5. x1 is 0.25. So we're going to put x1 there. We're going to type 0.25 into there plus equals. We're then going to do our bit of iterative formula nuts. We're going to do cos. Oh, I'm in degrees. Oh, it's okay. Cos the minus 1 of ants over 2 ants plus 5 press equals 2. Is that right?
Yeah.
Naught. It's what?
Right.
What's not in? It's in. Is that in the? Yeah. Thanks, Joe. Everybody's trying to be a director today. 0.23. What was it? Find the root correct to 3 significant figures. So we're going to write 0.2, 2, 3, 9, 6, 6, or something like that. That's x2, isn't it? Sorry. Oh, it's x, it's not you. I was just thinking I could do the YouTube joke, but I can't. Right, anyway. X3 is 0.24251. X4, 0.24172. We're looking for it to 3 significant figures. X5, 0.24194. It's looking like it's 0.242 very much, isn't it? X6, 0.24188. I think that's enough, isn't it? We're convinced at this point that to 3 significant figures, x equals 0.242 to correct to 3 significant figures. Are you alright? You're right, Joe?
Yeah, I'm just looking at the graph.
Okay. So, happy with that? We've got our answer. You have to present your answer separately. It's not enough just to show the series of iterative values. You have to complete it by saying, therefore, the answer is... Right. Part 3. I've not... Sorry. Show the result of each iteration correct to at least 4. So we did it to at least 4. Right. Part 3. 2 new curves are obtained by transforming each of the curves by the pair of transformations, reflection in the x-axis followed by reflection in the y-axis. State an equation of each new curve and determine the coordinates of their point of intersection, giving each coordinate correct to 3 significant figures. So there's a nasty kind of load of stuff at the end of this. Let's think what this all means. Transforming the curves, a reflection in the x-axis followed by reflection in the y-axis. So let's work our way through these. The first curve was, where was it? X brackets 2x plus 5. If I reflect that in the x-axis, you get that reflection, don't you, by multiplying the whole thing by -1. That reflects it in the x-axis. So in x-axis, that's going to give us minus x times 2x plus 5. And then to reflect in the y-axis, we need to replace x with minus x in every case that it appears. So if we're going to reflect in the y-axis, that's going to become minus x times 2 lots of minus x plus 5. So that ends up being y equals x times 5 minus 2x. There's my new curve. Does that make sense? Do you see the two transformations? So we multiplied it by -1, then we replaced x with minus x, and that's what it ended up being. The other expression was cos to the -1 of x. If I reflect that in the x-axis, it goes to minus the cos of cos -1 of x. If I reflect that in the y-axis, it goes to minus cos to the -1 of minus x. So that's my other equation. There they both are. State an equation of each new curve and determine the points of the coordinates of the point of intersection, giving each coordinate correct to 3 significant figures. Well, we've got our graph. Let's think this through graphically. If I'm reflecting each curve in the x-axis, that's reflected downwards, so the whole thing is reflected downwards. And then reflecting each curve in the y-axis, so I'm reflecting over that way. So my new coordinate is going to end up in this quadrant down here, isn't it? And its x coordinate and its y coordinate are both going to be the negative of what they were before. So the new point of intersection I'm not going to do any calculations. The question doesn't want me to do any calculations. It doesn't want me to work anything out at this point. It just wants me to write down what my new coordinates are. I may need to work out the y coordinate. The new x coordinate is going to be x equals minus 0.242. The y coordinate, did I work out the y coordinate before? I don't think I have at any point, have I? So to work out the y coordinate, I need to sub that into either one of my equations. So the y value would be, let's do it into that one, minus 0.242 times 5 minus 2 times minus 0.242, giving me whatever that is. Minus 1.33 it should come out as. Oh, syntax error is apparently the answer. Minus 1.33. Thanks, yes, and that completes a long two-part question.